having a short study on Kubernetes, but locally. I'll give him a chance to introduce himself later. So before we begin, I can tell you a bit about the community and some ground rules. So Kadima, please, next slide. So our quote of today is that will build up more as we continue.
You're broken.
Sorry?
A little bit. We lost you a little bit.
Oh, sorry. So I was saying routine today, you get a reward tomorrow, and we'll get to hear more about that as we continue next. The other one, sorry, next. So what is one small habit or daily routine you can follow that you believe will lead to big rewards in the future? And how has it impacted you so far? So please participate by either sharing in chat. What is one small daily routine you follow that you believe will lead to big rewards in the future? And how has it impacted you so far? Let's share in chat. Yeah, we have Chacha saying waking up at 5 a.m., but he hasn't started, so it hasn't impacted him yet. So what is one thing that you feel you can do to change to be able to start? As you know, small routines build habits. Okay. We see a few responses. Going to the gym. Have you started? I have a notepad. I save everything I want to learn. That is good. Writing everything new that you come across. Kevin, less procrastination and prioritizing. You can work under pressure as long as there's a deadline looming. Okay, Will says arriving on time, every place I go to or invited, time management, good. Meditation, okay, meditation helps with the stress management by Brian. We can have a few more. Morning exercises, I've tried, I've given up on that. Journaling, okay. Keeps mind clear, okay. John, I see you started doing programming. Keep the commits consistent daily and do meaningful commits. We can have some more. Writing everything, yeah, creating a list before starting your day, nice. Objectivity, okay. Reading books, one chapter every morning okay, nice. What books? Self-help, programming, what kind? And who has been your favorite author since you started reading, Jerry? Okay, so the reason why we have today's being routine today, reward tomorrow, it's because that we do not rise to the level of our goals, we fall to the levels of our systems. So work on building your systems more. Next. So about the community, we are a DevOps community, and we aim to create supportive and inclusive community that values diversity and supports learning and growth. Our vision is to be a leading DevOps community in Nairobi and beyond by empowering professionals to excel in their career. Okay. If you want to help or participate in the community, you can do so by running a workshop or giving talks that come easy to you. Professionals who can give quality talks that we can all learn from. Give feedback and share ideas that you come up across and you feel like can improve the community. You can also share our posters on social media and however you can to someone who will be able to learn from them. You can also help in organizing events and branding. The next one, please. The next slide. So you can join our community in either of the following ways. We are on LinkedIn, WhatsApp, Twitter, and Discord. Yeah. Next. So our today's topic will be from one of our past events, which was DevOps Days. So for those who missed to attend DevOps Days, you have a chance to have a walkthrough by Moses Mbadi, who was a wealth of DevOps engineering and full stack. He will introduce himself more, and you'll get to learn what you need during that day. So Moses, please introduce yourself.
So we can't hear you, Alvin.
Oh, sorry.
So, but I think what you were saying is just introducing the speaker for the day. So today we are going to have our speaker, who is going to be James Mbadi. So James Mbadi, maybe you can take over now. You can just share your screen, and then we'll have any questions that you have for the community. We'll be able to respond to the questions at the end. So meanwhile, we can just have James Mbadi take over. Yes, James.
Okay, hi everyone.
Moses, actually, not James.
I was wondering if from your end it
Sorry,
reads
sorry.
James.
Yeah, sorry about that.
All right. Thank you very much. I'm glad to be here to have a discussion, really. I'm not really very experienced in DevOps. I'm just an avid learner. I try to push myself as much as I can. I'm hoping I'm audible enough.
Yes, you are.
All right. So how I'd like to start this, I would like to understand my audience so that at least I try to curate what I have to share today to suit the audience. And therefore, I have a couple of questions that will help me sort of just, break some ice. And I would start by asking, who among the audience, just by show of hands, who is a total beginner in DevOps or programming? Like we're looking at maybe, let's say, less than a year of experience, just by show of hands. Okay, 2, 3, 5 people. And who has, say, 2 years of experience in programming or in DevOps? 2 years of experience, anyone by show of hands? All right, 4, 6, 7 people. And I just want a member from the audience to sort of like share as one of the biggest challenges that they've had to go through while learning tech in general. Doesn't have to be DevOps, but programming, cybersec, if you're into that. Would you just maybe in less than 30 seconds share some of the biggest challenges you've faced? I don't know, maybe Samuel, you can help me. Someone has their hand up. Rosalind?
So let me allow him to talk, but we
Okay.
muted people, so we encourage people to use the chat.
Oh, okay, cool.
Yeah. Let me see. That was
Rosalind. You can also share in the chats if you're comfortable with that. Just some of the challenges you've had to tackle while learning tech.
Roslyn, you should be able to speak now.
Oh, yeah. Hi, everyone. I hope you can hear me.
Yeah, we can hear you, Rosalind.
Okay. So my greatest challenge has been definitely deployment. And yeah, so I just started that part very recently. I've just been focusing on backend server-side logic. So when it comes to deployment, and especially because I use Django, preparing everything for deployment there has been a huge entry barrier there for me. So I'm hoping to catch a few things tonight. Thank you.
All right. Thank you, Rosalind, for that. I'm hoping what we'll cover today will at least shed some light and try to ease the process for you. Okay. And I guess the last question, maybe you can just share in the chat, is how much in terms of percentage, how much of what you learned in college or university or in boot camps, how much of that in terms of percentage do you use in your let's say in your work, or if you're doing anything in tech, how much percentage do you use from what you learned in school? Okay, I see a 5% there. Okay. There's a 10%. Okay. Okay, there's another 10%. There's a 5%. All right. This is a 50%. Okay. Kevin, I would want to know which school you went to. I think they are teaching the right thing. Okay. If you were to ask me, I would say maybe 10 to 20%. Yeah. So that means you have 80% of what the industry requires in terms of skill set. You have to teach yourself that 20%. So that means, and you don't have time. You don't have time. That means you have to find a good strategy to sort of get that 80% in as fast as possible. You would probably spend maybe 4 years in the uni to get that 20%. So the question is, do you get the remaining 80% while you're in school, or you get the remaining 80% on your own? Yeah. And so today, we will be talking about Kubernetes, but in general, we'll be talking about deploying software. I'm hoping by the end of the session, I'll have lived up to your expectations. So I'm just going to share my screen. I'm hoping I share the right screen. All right, I'm hoping everyone can see my screen now. So let me just push this to the other side. So here's how we're going to do this. We're going to look at a few PowerPoint slides just to familiarize ourselves with what we are trying to achieve. And then we will move into now looking at the actual setup in action and try to see if we can catch a few bugs and talk about those. And we will end the session with a few questions. So I'm just going to share my slide here. Okay. I don't know why it's displaying. So I have to share a different screen. All right. So a little introduction. I'm Moses Mbadi. I'm available on probably all the social media platforms as Moses Mbadi. I don't know which screen you guys are seeing. Which screen are you seeing? The one with 2 slides or the one with 1 slide?
We are seeing both, but the one with your image is bigger. But you can see the next one.
Okay, I think that's okay.
Okay.
I wanted to share the second screen, but somehow. Okay, let me just try to do that again. Okay.
Yeah, now
There we
it's
go.
fine.
All right. I'm not really active on YouTube yet. I'm yet to set all that up. So just okay. So first we'll have a chat on why we are here, what we'll cover today, and then we'll have a few words on DevOps. We will look at infrastructure as code. I'm using Vagrant for the reasons which I'll mention. We look at helper scripts. We look at how to connect nodes, and we will deploy a demo application. I hope it works, and then we'll have a few questions and answers at the end. The source code for this session is available at github/Moses Mbadi /K8-local-lab, or if you just search Moses Mbadi on GitHub, you'll be able to see the source code. If your internet and computer are both fast enough, you can just run the code with me, and we see how that goes. I also wrote an article on what we'll be talking today, on what we'll be talking about today. It's available on mosesmbadi.media.com. You can also have a look at that if you have some time. And I'll just jump straight into why we're here. So for you to understand DevOps, especially Kubernetes in detail, you need to understand the differences of how software was deployed and how we want to deploy software today. So how software used to be deployed is, okay, let's start with the first step is, of course, your plan. Get the requirements, have your developers ready, and then you develop the software. After developing the software, you build and test it. Everyone says it's okay. Now you provision the production servers, spin up maybe the database, backend, front end, if you're working in that kind of setup. And then you install all the necessary dependencies and you clone the project there or the source code. You run it, and if you're talking about changes to an already running service, you have to maybe take it down for a few minutes while you roll out the updates. So hence the downtime. And after you've rolled out the updates on the production server, you have to build and test it again. Everything looks good, you mark it ready. But how can we make the process simpler? So with DevOps, first you start by adopting the DevOps culture. And then now you develop the software. Okay, this is a little bit, the first item there is more of an umbrella. which covers the planning phase and the development phase, which also spreads to number 2. And then after that, you build and test locally, and then you push to production. And prod, in that case, you could think of it as just a source code branch. And that I've explained in my next slide, whereby you just develop your software. I'm just going to try and get the... okay, you just develop the software, you push it to source code, and then in source code, you can either push it to staging, where you have the QA team have a look at it and catch a few bugs. If there are any, make the changes, again, push to staging. And then once everything is okay, you push it to the production, and then the users can see the application. Now, this is a high-level presentation of the whole process, and I will maybe breaking it down as we continue. So what is the roadmap to learning DevOps? I would say first, you need to understand, you need to have knowledge of the technology stack used. If it's Django, React, Postgres, you need to understand how those services run on bare metal before you even move to now adopting DevOps. You need to understand version control. In this case, Git is most commonly used with GitHub or Bitbucket. You need to understand what CI is, continuous integration, and here you use tools like GitHub Actions, GitLab CI, Circle CI. You need to understand what CD means, continuous deployment, and here we are talking about GitHub Actions, again, GitLab CI. You have Ansible or Jenkins if you prefer those. Now here, I've added something here called a test job, and we'll be looking at what this is in the practical part. And here I've added build and deploy jobs, and we'll be looking at CI and CD. So once you understand the knowledge of the stack, version control, CI/CD, you understand the infrastructure provisioning and management. Now this is where we are for this session today. And here you can use tools such as Terraform, Vagrant, and CloudFormation. And then you have to understand deployment. How do you push your code to production? A little bit of my environment. In case you want to run this, I'm on a Lenovo IdeaPad 3. It's an i5 11th gen with 12 gigs, and 512 SSD and NVMe. I'm using Ubuntu 23.10, but I've tried this on WSL. It works okay. I haven't tried on Windows yet, but I think if you have VirtualBox on Windows, Vagrant can run smoothly as well. So that is on the environment. So far, any questions? Okay, all my screens are occupied, so I don't know if anyone has their hand up. Maybe Samuel or someone can check and let me know.
Okay, so if you have a question, you can just type on the chat, and then I'll be reading the questions as we go on. So utilize the chat box. So the reason why we are not allowing audio is so that we do not have interruptions, and also sometimes we get spams, and we are avoiding that so that we can have a good session. So just utilize the chat box, and then I'll read the question out loud for Mbadi to respond.
Okay, so, that makes sense. Yeah, so you can just read the chat and let me know, since I have my screens all occupied. Okay, so we will jump straight into infrastructure as code. Before you deploy your code, you need to set up the production infrastructure. How many servers you need, if you need multiple servers, how will the code changes be rolled to production, and things like that. So in my case, I'm using Vagrant. Someone asked why I'm using Vagrant. It's just a matter of preference, really, and it works awesome locally. You can use Terraform, Jenkins, but that comes with an overhead of configurations, a nightmare, which I didn't want to handle. And when I started this project, I just wanted to make it easier for other learners to learn Kubernetes. So I wanted to make things as easy as possible using tools that are, easy to work with. So I'm using Vagrant to set up my infrastructure. And with Vagrant, all you need to do is you need to install Vagrant, which can be found on the official documentation. And then once you install Vagrant, you need to create what you call a Vagrant file. You need to create what you call a Vagrant file, just like that, no extension. And then now inside the Vagrant file is where you specify how many servers you want, what dependencies you want installed on those servers, and a few other things such as the resources to be consumed by those servers, which I've defined here. So in my case, since we want to set up a Kubernetes cluster, we have the concept of a master node and a worker node, which you see these two here are just worker nodes, and this is a master node. And once we get into the code, we'll be looking at how this infrastructure works in Kubernetes. So basically, just to go through, the Vagrant file tells us how many nodes we want. And the nodes in this case, I'm using interchangeably to mean like servers or computers. The networking configurations, which folders are we mounting from my local computer, and a few helper scripts. Now, what is the importance of helper scripts? The definition I like to go with of Kubernetes is Kubernetes is a collection of computers. It can be 4 or 5 computers with special tools or software installed on those computers, which effectively converts them into what we call a cluster. So you have a master node, which is like the head boy or the chief, and then you have worker nodes, which now carry the bulk of what happens in terms of running applications. So in most cases, not really in most cases, but you will interact with the master node to give it commands on what you want. So if you want to deploy, let's say 3 applications, you tell the master node, I want to deploy 3 applications, and then the master node's work is to find out which worker node maybe has enough free space or enough resources to run these applications, as well as other parameters that you can pass in as you run the nodes. So once we create the Vagrant file, all we need to do, okay, here I tapped Vagrant status just to check if my nodes are running or they're all down. And then you can type Vagrant app to bring up the servers. And then Vagrant status, of course, will tell you if your servers are running or not. And then if you want to SSH into a specific node, you do Vagrant SSH, and then you give the name of that server. The same with if you want to SSH into a specific worker node. So now at this point, we have our nodes up. We have 3 nodes running. We have a master, node 1 and node 2. Just think of this as a master node, this of worker node 1, worker node 2. So how do we connect the nodes? Remember I said Kubernetes cluster is essentially multiple computers connected together with special tools installed on them. So once you have your nodes up, you just issue the following commands. First, you SSH into the master node, and then you initialize it using this. Now, pay attention to this IP address and the subnet mask for our pod. Of course, this might not make sense right now, but you'll see as we proceed. So once you run this command, it will give you a token and a certificate authorization, certificate authority. Is that okay? CS certificate. Now, those two is what you'll use here to connect the worker nodes into the master node. And once you've connected, you need now to deploy your application. And this is the most important part because you need to think about what your application needs to run. If it's a backend service in Kubernetes, you need a namespace, you need an environment variable, you need an object to hold environment variables, you need static file storage, you need a container image, and you need a service. Now, here I'm referring to an application such as Django. Here I'm referring to an application that runs with let's say React or Next.js. So you need a namespace, you need a container, and you need the service. For a database, you need the same. Now, just reading here, you will see that certain things remain constant. You need a namespace for any service you deploy to a Kubernetes cluster. You need a container or the image that you want to deploy, and you need a service which will give your application networking capabilities. If it's for database, you need the same, but I forgot something here. You also need a storage to hold your data. And this is a sample deployment of a front-end application. Of course, you see the namespace here, you see the service, and you see the deployment. Now, the deployment tells us which image you're trying to deploy. And here I've referenced Moses Mbadi EasyMade frontend. Now, by default, this will pick Docker Hub images. I don't know if there's anyone who doesn't know anything about containers, so that you don't leave anyone behind. So if you're completely new to containers, you can just say it in the chat, and then we'll just have a few words about it. So this is a sample deployment. Now, after you've created this, what now do you do? There's a command you use to tell the master node that you want this application deployed, and we'll look at that once we go into the practical session. So there are a few things, there are a few important things you need to consider when working with Kubernetes. So you need to think of the namespace. Each application, each service on a Kubernetes cluster runs under a namespace. If you don't specify the namespace like we have done in the previous slide, your application will run in the default namespace. Now, in terms of management, just to make things easier, I like to define specific namespaces for specific applications, so it becomes easier to troubleshoot in case you have an issue. You also need to have an image, which is a Docker Hub image in this case, and you need to have a service. Now, in the service definition, we have the port and type. Now, we look at an actual deployment manifest, and you'll see what these are. But yeah, these are the things you need to consider as you deploy your application. So what are the general steps for deploying an application on Kubernetes? You create the manifest, the service, the deployment of the namespace. And after you do that, you just run this command, kubectl apply easymade.yaml. And then just to check if your pods are up and running, you tap this command to see your pods. Now, notice here I've passed in the namespace here, just to get the pods that are under this namespace. And then kubectl get service -a will get all the services in the cluster, but you could also replace -a with -n easymade, and it will get all the services under easymade only. So that is just a little theory before we jump into the practical part. So far, does anyone have any questions?
Yes. So there is Chacha, who is asking if you are running the Vagrant commands on your virtual environment or on your host.
Chacha, I'm running the Vagrant commands on my host because I only have one instance of Vagrant, which I'm using to manage all the other nodes.
Okay, so there is another question from Joseph. He wanted you to explain more about containers. So I don't know what exactly you wanted, but maybe you can talk a little bit about containers.
Okay. Sorry, when I take a few minutes, I'm writing the issue down. I solve problems better on paper before I write the code. Okay. Is there another question, or I should proceed? Sorry, someone, I didn't get that.
So those are the only questions.
Okay, sure. I will proceed. So we'll have a look at, I'm trying to share the screen. All right. So a little bit on containers. I'm hoping I'm sharing the right screen. Let me just close all these first. Okay, so a little bit on containers. Let me just open this project in VS Code. So if you are given a project to run locally on your machine, let's say it's a Django based project, and it has its own dependencies. So normally what you need to do is you need to create a virtual environment, and then you CD into that virtual environment. And I think I have a README here that explains. Wait, what am I doing? Not that. This is what I need. Okay, so as I've explained in the documentation here, you have to create a virtual environment. You CD into that virtual environment, and then you install the dependencies, you run migrations, you migrate, and then you run server. This is easy, but imagine you forget to activate your virtual environment and you install the requirements. That means these requirements are being installed globally. So if you have, let's say, 3 Django applications on your computer, and each depend on separate dependencies. Now they will conflict when you try to run one, you install the dependencies, and then you try to run the other one, they will conflict. So that is now where the concept of containers come in. So a container basically just takes all these and packages them into like a small deployable unit. You use what we call a Docker file. So the first step is, of course, you install what we call Docker. In my case, I do use Docker Engine. But if you're on Windows, Docker Desktop works fine. So you install Docker, and then after you install Docker, you create what you call a Docker file. In my case, if I look at my backend Docker file, this is how it looks like. Let me just close this. If I look at my backend Docker file, it just contains the same steps that we do when we are running on bare metal. So first you start with an operating system. People do refer to this as a base image, but I just say it's an operating system. Wait, why is my selection not working? Okay, let me try this. Nope. Okay, not sure why my selection is not working. Anyway, you start with an operating system, and then you do some configurations. After that, you install some dependencies here and here. And then once, why is this not selecting? Okay, once you install some dependencies, you now run your application, and these are the commands to run an application. It takes a while to understand all these commands. So what I would recommend is that you look at multiple projects that run with Docker, and then you just try to read through the Docker file and see the similarities and the differences. That can help you understand Docker more. Now, if you are running a front end, you will again create a Docker file, and then inside that Docker file, you start with an operating system, you create a working directory, you copy your requirements, you install them, you copy the source code, you build the application, and then you run the application. Now, these steps are the same with what I was showing earlier. Like, for example, if you wanted to run a Next.js or a React application, you would do npm install. You will, of course, in the source code directory, and then you do build, and then you run if you're running in production server. But if in development, you're running with this. I'm trying to go fast so that we get the job done in not as much time. So if I've skipped anything that maybe has confused you more, you can just say in the chat, and then you can pick it up. Now, this is what you call a container definition, or you can say just an image definition. So after you create this, what next? You have to build what you call an image. An image builds a container. So you can think of an image like a small operating system. Think of it like, for example, if you buy a new laptop, you install Windows on it. Before you install Windows, you get the Windows image. So an image is just a portable, deployable application. So once you get that image, you install it on your computer. So in our case, once you have the image, you can run it anywhere. You can run it on any computer with Docker installed. So step 1, you need to install Docker. Step 2, you need to create a Docker file. Step 3, you need to build your image. Step 4, you need to run your image. Those are the 4 steps for containerizing an application. So if you're containerizing a JavaScript application, you in most cases will use a node-based base image. If you're containerizing a Python application, in most cases you'll use a Python-based image. If you're containerizing an Nginx application, you would in most cases use an Nginx base image. And yeah, that's just about it about applications. Sorry, about Docker. So
Thank you.
So
There
I'm
was
going
a
to.
sorry. So there was a follow-up question here.
Oh, okay, sure.
Yeah. So you have 2 Docker files. Do you hold the production and development configurations differently? Do they hold the production and development configuration?
No, it depends on how you're deploying your application. So there are 2 ways you can deploy an application. You can use what you call a Docker Compose, or you can deploy it on a Kubernetes cluster, or you can run the images manually yourself. So for example, let me just open my notepad here. Just close this. So now, so if you have the 2 Docker file, there are 2 ways you can deploy the application. You can use a Docker Compose, compose.yaml file. Okay, it's a Docker Compose, but I've just renamed it Docker Compose file. Or I don't know if this is visible, or you can deploy it in a Kubernetes cluster. It is cluster, or you can run the containers manually. Now, if you are deploying it with the Docker Compose file, all you need to do is create a Docker Compose file, Docker Compose.yaml. Then you just run Docker Compose app, just like that. Let me just do this. But if you are deploying it in a Kubernetes cluster, you need to create the manifest. And then you run kubectl, apply, you specify the file, and then you manifest.yaml. This is what we'll be looking at today. But if you're running it manually, these are the steps you generally use. So if your image is built already, you don't need to build it. But in most cases, you'll need to build the image, and then you run it like that. Let me just get rid of this. Yeah, so these are the 3 ways you can deploy your Docker containers. Maybe there could be more, but these are the most used methods. Okay, just to have a look at a sample Docker file, Docker Compose. So here I've created you will notice I've used a .local here just to separate my production setup from my development setup. And here in my Docker Compose local.yaml, I've specified 1 Docker file which comes from the backend, as you can see it here. Okay, my VS Code is misbehaving. I've specified this, which comes from the backend. So this will go and build the image I've specified in this dockerfile.local here. And then the other one is my front end. Okay, there is a worker, there is a Celery worker, and there's my front end. So my front end, again, I've told it go to the front end directory and run the Docker file specified there. So what Docker Compose will do first, it will build the image and then it runs the image. So Dockerfile simplifies this process for you. If you had multiple images, now you have to run these commands in duplicate. Okay, sort of in duplicate. So here you would have Docker build front end, and then Docker run front end. Please ignore this. I'm just trying my own things. So you would have to run all these commands if you're running Docker manually without Docker Compose. But with Docker Compose, once you create the Docker Compose YAML file, you just do Docker Compose app, and then it runs your applications. Yeah, so that is what I've done here. But this is now locally. And so if I wanted to run that, for example, I would just say Docker Compose, and this should be up. And then, of course, it detects that my images were already built, so it does not go through all the work of building the images for me. And if we just go to the browser, we can see that the application is running using Docker Compose. Yeah, I would go through how to run it manually, but in the interest of time, let's not do that. Any questions?
I think so that is fine. So we'll, I can keep on posting the questions on the chat. And because of time, we can just respond to all questions maybe at the end.
Okay, so before we get started, we've of course defined our infrastructure inside Vagrant, but what do we need to have before we get here? First, we need to have our images built. So I'm just going to Docker Hub just to confirm that my images are all there. I'm just going to sign in. Oh, this, okay. So I have my images built. I have the backend image and the front-end image already inside Docker Hub. So that is the prerequisite. Now, the other prerequisite is that don't try this on a 4 gigs of RAM. Your computer will toast. Probably try with 8 gigs and above. Okay, so this is our Vagrant file. Vagrant uses Ruby, but don't worry about that. You don't have to learn Ruby. This is pretty much all you need to understand. So first, we've specified the resources we want each node to be given. We've started with our master node. Remember what I said, that a master node is like the headmaster. It's the chief. We've started with the master node. We've given it the IP address, and we forwarded we forwarded this port. We've given it a name, and we've
Moses,
mounted.
so there is a request that you zoom in.
Oh, okay, sorry. Let me just close this.
That's better.
That's better. Okay, we've given it the IP address, and we've shared some folders from my root, from my host, from my Vagrant host, the computer running Vagrant. And here we've specified one node. We've given it the IP address. We forwarded this port, and we've mounted we've mounted this directory. Next, we've specified node 2, worker node 2. We've given it an IP address. We've forwarded these ports, and we've mounted these directories. Now, the disclaimer is I've already run it on my computer just to save on time, because if you run this again, it will take quite a while because it needs to download the base image, which we've specified here. Oh, I forgot to mention the base image. This is the image that our servers will be running on. So it needs to download this image and then run it. And at the end here, okay, I ran into a few bugs. That's why I had to comment out this slide. But I have a few helper scripts. Now, basically, these helper scripts will install the tools I mentioned earlier inside our nodes. Remember when I said a Kubernetes cluster is just a collection of computers with special software installed on them, effectively making them a cluster. So some of the tools are like this one here, KubeADM. Another one is a container runtime, containered, of course, a script to just set up the networking for us, and a few other essential tools. Now, if you can get access to the source code, you can just go through the scripts and understand what each script will do. So once we are done with the Vagrant file, this is our infrastructure, how it will look. We can now jump into the terminal and run and fire up our infrastructure. So the command you'll use here is Vagrant app. This will fire up your nodes, but I've already done that. So what I can do is to do status.
So you can also zoom in your terminal.
Oh, okay. Let me just wait. What am I doing? Turns out Control Plus doesn't work here. I don't know why.
Control Shift Plus.
Control Shift Plus. Oh, perfect. That's better.
Yes, it is.
Okay. So where are we starting? We are starting with installing Vagrant, and I can just use a notepad here to sort of. So step one is to install Vagrant. Step 2 is to create a Vagrant file. And then we go to step 3, fire up the servers. After you've run Vagrant app will go through your Vagrant file, detect how many nodes you want, and then it turns them on, install the operating system, and then run these scripts to install the tools that we need. Once that is done, you can do a Vagrant status, which will tell you the status of your machines. So mine are in saved state because I did run Vagrant suspend. But here, to bring them back on, I can just do Vagrant resume. Now, to understand these Vagrant commands and what they do, you can just do Vagrant. It will tell you what these commands do. So we have reload, which basically detects some changes in your Vagrant file. We have Vagrant push, if you want to build the image and deploy it somewhere for other people to run it. So in my case, for example, if I do a Vagrant push, someone else can download the images and run the cluster as they are. You won't have the overhead of configurations and installing the scripts. So you can just do Vagrant, and then you look at all the commands you will need. In our case, we will use this and app. Of course, I've already mentioned app. Suspend, if, for example, you want your machines to go to sort of like use less resources, I guess. I don't know how to explain that. Okay. So we are going to do Vagrant resume just to fire up our nodes. That will take okay, that takes a few minutes. So probably if there's a question now is a good time to answer.
There is no question on the chat.
Okay, okay. And if I'm going too fast as well, you can just maybe mention it. This also actually depends on your internet speed and computer processor. So if you have a faster, more robust processor, this might be faster. Okay, node 2 is up.
There's a question here from Grievin.
Okay, sure.
Since in software everything is a trade-off, why would you choose Vagrant over Docker and vice versa?
Okay, Vagrant and Docker do serve two different purposes. Vagrant helps you to spin up the infrastructure, but Docker helps you to sort of containerize your application so that they run as separate units. So I use both. As you have seen in development, I use Docker Compose, or I can even run the containers manually. Okay, now we can do Vagrant status, and you see, okay, so our nodes are running, master node and node 1 and node 2. Now, the next step here is to SSH into the master node because we need to tell it what to do. So we do Vagrant SSH master. So I'm using, okay, for let me just pronounce it this way. I'm using Zish terminal. So Zish terminal basically does that kind of suggestion, making your work easier. And then you can just do the arrow key right, and it completes the command. So we are going to SSH into the master, and of course, once you SSH, it gives you some information here. Now we are in the master. You can notice the difference in the prompt from this to this. Now this tells you you're in the master node. So once we're in the master node, before we deploy an application to our cluster, we need to confirm that all our nodes are well connected and they're up. So here, what we need to do is we write kubectl get nodes, and then it tells you, oh, okay, one node is not up. I don't know why. Okay, I'll figure that out later. So this tells you the number of nodes you have. As you can see here, this is tagged as the control plane. Just think of it as this means the one who is in control. That is why we've SSH into Masternode, because this is where we'll be running most of our commands. Now, kubectl is part of the tools I mentioned earlier that will be installed on the nodes. This helps you interact with the master node. It's some people say this helps you interact with the API server, but I try to move away from terms that confuse people more. So this basically is what we'll be using to interact with the master node or with how can I put it? Okay, with the master node. Let's just go with that. So we can see now our master and our worker nodes are ready. Now, the second thing we need to do is we need to create our manifest. People say manifest, but we need to create our deployments. Now, you remember when I said, for example, in the case of Django, and I want to see which folder I've mounted here. So I'm just going to CLS, I'm going to do ls shared. I think I will create the files here inside master. If I do ls shared master, manifests, I can do manifest. Okay, so we already have this here, but I wanted to create them, but I can just do this, master. Okay, so here is empty, so we can work with this. So inside master, I'm going to create a directory called manifest. And then I'm going to create another directory called management. Now, management directory will hold all the manifests that we want to deploy for services that have something to do with management of the cluster, such as the Kubernetes dashboard or Portainer or any monitoring and metrics collection software. Now, inside manifest is where we will deploy. This is kind of bothering me that we have data here. So I'm just going to delete everything here first. No, remove ref. Let me just do master manifest. No, let me remove everything inside manifest. Okay. Let's see. Okay, all good. So here is where we will create the manifest for the applications that we want to deploy. So one way to approach this is to create another folder here called backend or API. And then you remember what I said, okay, we can create them all so that we can create the front end and the backend. So what will we need to deploy a Django backend application in the Kubernetes cluster? First, we will need service.yaml. Next, we'll need a deployment.yaml. The other thing, we will need a PVC, which is essentially a storage, like I had mentioned before. So we will need, let's just say pvc.yaml, c.yaml. But we are not going to do any of this because this is kind of hard for me to manage. So what I'll need to do is I'll just create one file inside manifests. I'll just create a file and say easymed API.yaml, just like that. And then now inside here is where I'll specify all the objects that I need. So I'm just going to copy paste from something here. Okay, just let's do this. I'm going to use the source code to copy the. Okay, I think my computer is misbehaving.
as he tries to copy, maybe if you have a question, you can post it on the chat. So Samuel Masharia has a question here, I think. The Docker file for the front end is placed in the same or different directory from the Docker file of the Django, of the backend.
They are placed in two different directories. Basically, okay, if you are outside the Kubernetes cluster, they are placed in two different directories.
Okay, so there's another one as well from Jerry Juma. Will this setup run on-prem VMs? I have access to the lab servers and I usually get processed with the Calico plugin.
Sorry, will it need? Okay, I'm using the Calico plugin, but I didn't get the first part. What is the first part?
You wanted to know if the setup would work on-prem VMs.
Oh, yes. It's just the same way I'm using here. I'm just using VirtualBox to manage my virtual machines. So in your case, if you have physical virtual machine, if you have physical servers, you can just repeat the same steps. Okay, I think I deleted the wrong folder, so I'm trying to
Okay.
manifest. Okay, so so first we start with the namespace, and I think we will start. Let's get rid of this first, and then we create a front end. I can't get the one for backend, and I don't feel we can type all that right now. So we'll just do easymade front.yaml. And then now inside here, we start with the namespace, which basically says you want application to run under the easymade namespace, just to separate concerns. After we've created our namespace, we need to create a deployment. And I'm just going to copy the deployment here. Now, the important thing you need to notice with the deployment is this image, the easymade frontend. This is going to be picked from Docker Hub, the one I showed you earlier. Then after we've created the deployment, we need to now create a service. A service is what gives our application networking capabilities. So, okay, sorry, I need to copy this here. Now, so you will notice that I'm using all the objects. Okay, let's just call them objects. The deployment, namespace, and the service. I'm using one file to define all of them. Now, the method I started with earlier is where you create a folder here, and then you separate these ones into separate files. But it becomes a little bit difficult to manage. So that's why I'm going with this method. So after you've created your service or your deployment or your manifest, what is the next thing you need to do? So you need to tell Kubernetes to run your application. And in that case, you go back to the master node. Okay, I had SSH into. So you go back into the master node. We can try to see. Okay, I keep forgetting the path for this manifest. Okay. Not sure why it's not reflecting here. Where have we created our manifest? Master manifest. Okay, we can still do this. I can just don't know if it's my machine misbehaving. So I'll just create the file here. I'll say nano ismed, let's say fr, so that it doesn't clash with the other one. And then I'll paste it here. So I'll save it. So now after you've created your manifest, let's just see if it's there. After you've created your manifest, there's only one command you need to run, and that is kubectl apply. Then you specify the file. You want to pick this file. So I'll pick it, I'll paste it here, and then you hit enter. Oh, okay, I'm typing my own things. kubectl apply. So it will tell you that this is created, this is created, this is created. Now, so what happens here? What will happen is Kubernetes will go to Docker Hub, it will download this image, and then it will run this image. So right now, if you try to access your application, there's nothing there because the image is still being downloaded. It's quite large. I couldn't figure out how to make it smaller. So the image is still being downloaded. But basically, to deploy an application on a Kubernetes cluster, you need to think of what that application would require. In our case, we need a namespace. We need the image to run, which will be specified under the deployment object. And we need a service which will give our application networking capabilities. Now, these three things, you can think of them as Kubernetes objects. That's what other people say. So when I say objects, this is what I mean. I mean this, and I mean that. Now, if you don't specify the namespace, your application will run on the default namespace. And if right now we try to check, if we say kubectl get namespaces, we can see we have these namespaces. Now, here's why I try to separate applications into their own namespaces. So if you do something like kubectl get services, and then we say get everything, you see we have all these services already running. Now, if you wanted to delete services under a specific namespace, or if you wanted to, if you had a namespace managing, let's say, 10 services, now you would have to delete them one by one if they are under the default namespace. That's why we try to separate the namespaces. It also becomes easier to manage them because if I want to know what's going on under a specific namespace, I can say kubectl get services, and then I specify the namespace, ismed. So this tells me I already have this application running, the one we've already deployed. If you want to know these commands, again, you just type kubectl. It will tell you all the commands available and what you can do with them. Now you would notice I try to stick with the inline documentation provided with the CLI tool. This really does a good job explaining what the commands do, and of course you don't run into a lot of problems typing the wrong commands. So again, we are going to get the. I'm lazy. Let me just do this. So we are going to try and access our application on this port. So just the browser. So first, I'll get the node IP. So I'll go to my Vagrant file, and then I get the node IP. So right now, if you try to access the application, it shows nothing. Probably it's because the image is still being downloaded. So we might have to give it a few more minutes. While it does that, if there's any question, if there's anything I've skipped, I've lost two important files. That's why I was a little bit disoriented. So while you wait, so now after we fired up our servers, step number 4 is to create manifests. or objects that we want to deploy. In this case, we specify the namespace, the deployment, and the service. And then step number 5, we deploy. So by deploying, we do kubectl apply, we specify the file to our deployment. So it could be, let's say, manifests stroke frontend.yaml. Just like that. So after you've deployed, we need a few commands to check if our services are up. So that we use kubectl get services, and we specify the namespace name. Yeah. Okay, now the container is built and we can access our application. So notice here we are using the node port to access our application. What if we use the master node? Let's try that. Let's try the master node. So if we type the master node here, it takes a few seconds. Okay. We should be able to access our application on the master node as well. I don't know why it's taking ages, but at least we can access it on the one of the worker nodes. So there is a bunch of files here. I think it's a little bit confusing, but just to recap on the steps. Number 1, you install Vagrant and you create a Vagrant file, which you've done here. The Vagrant file essentially will carry your applications. It will. It basically tells you how many nodes you need, the networking infrastructure, the IP addresses, and then you mount the shared folder. Now, this is what has missed me a few seconds ago, but it's okay. So after you create the Vagrant file, you fire up your servers. This you do by issuing the Vagrant app command. After that is done, you create your manifest or object. So if it's just a simple front end, you will need a namespace, a deployment, and a service. Now, this and this, it's just a matter of the configurations you write. But this one, you need an image to be on. I'm trying to. Okay, my browser is as well misbehaving. So you need to build an image, a Docker image, and push it to a container registry. In our case, we are using this image you see right here. So after you have your image, you specify it in the deployment object. After that is done, you deploy your application. You just say kubes deploy. This should be okay. kubectl apply, and then you specify the object file. Once that is done, you get your services. You say kubectl get services. Now, there are a bunch of commands that you can use in your cluster, not just kubectl get services. You could do things like kubectl get pods, and then that tells you how many pods are running. This one is in pending state. I'm not sure why, but the application is already running. So once you fire up your application, you kubectl apply, kubectl get services, tells you how many services you have, and then that's it. Now, that is not everything that Kubernetes entail. In more advanced setup, you would need to set up a web server like Nginx to handle traffic from certain applications. Into certain applications. So here I've just used a simplified version of that. This is what you worked with. Okay. Are there any questions?
Okay, so I think we can just take a few, the ones that are already on the chat.
Okay.
So I can see here, Benson asked, what's preferred, picking the image from Docker Hub or artifact registry of the cloud platform you're deploying?
Okay, artifact. Okay. I'm not sure. I just prefer. Okay, let me just mention something here. I forgot to mention. So So you see, with picking the image from the cloud, I do not have to worry about the images. So in the project that I have deployed, the EasyMed frontend, so I'm using, now where is it? Okay. Try to look for it. So in the EasyMed project, I'm using GitHub Actions to automate my build and pushing to the container registry. So all I have to worry about is, as you can see, this is the CI job. So when I push to a specific branch, it does all the building and logging into Docker Hub and pushing the image there. So from the development setup, I just push to a specific branch. And then now from the Kubernetes cluster, I can just pick the image. Now, I don't know which method is preferred. I guess it's just a matter of what works best for you. For me, it's just picking the image directly from Docker Hub. Has, less stress. And I think this setup will work based on an on-prem infrastructure.
Okay, so I think his question was also asking to compare if there is any advantage of choosing either to use Docker Hub or to use the cloud provider where you are deploying your resources to as also your store for your images, or where you're going to access the images from.
Oh, okay. I get it. At work, we use GitLab. So GitLab has a CI registry. We don't use the registry provided by GitLab at work, but it has that option, which means you could just store your images inside your sort of source control server. I know it's different from what he's talking about, but again, that means you have to handle a lot of configurations and security when you're doing that with that kind of setup. Now, I don't know if it's any different from a cloud provider's CI registry, but I guess maybe you could just give it a try and see how it goes. I've never stored them in something like AWS, so I don't really know if it has its own disadvantages there. Yeah, maybe it's something I could look into later and have a chat on that.
Okay, thank you. So there is Timothy asking, how big or small should a Docker image be?
Okay. It depends on the specific service you're building. So for example, for front-end application, a Docker image will basically have the node modules inside it. So that means it can be quite big. Docker node modules, depending on the dependencies you put in there, can go even up to 2 gigs or 1.2 gigs. But for front-end applications, I try to play below 1.2 gigs. For backend application, because there isn't much in terms of data that you're storing there, I'd like to play below 600 megabytes. Yeah, for things like the database, I don't advocate for storing databases inside containers, but you could play with something less than 1 gig. What else? Things like a web server, like an Nginx, handles very lightweight stuff in terms of data, so that you can have it coming in at maybe, let's say, 200 megabytes. Yeah.
Okay, thank you. So there is one more question from Godwin.
Okay.
Why are we using 3 nodes in the K8 clusters? Can we use less number of nodes?
Yes, we can use less number of nodes. I think currently okay, let me just kubectl get nodes. In my case, I'm using 2 nodes only. But in the Vagrant file, I specified 3. Somehow one did not make it. But you can use as many as you want, or as few as you want, depending on the resources on your laptop. Now, the reason why I did not go with one one cluster node like how Minikube does, it's because I wanted to have an environment that is as close as possible to a production environment. In most cases in production, you're not working with one node because that beats the purpose. Then you can just as well use Docker Compose. But I wanted to have a setup that is as close to production as possible. So that's why I separated the master node and the worker nodes.
Okay, thank you. So that is the last question. Back to you if you have any last words. And there is one question that has popped in. How many containers can you set in a how many containers can you set in a pod? That is from Peter.
Probably 3, 4, I guess 4. Okay, I don't know the maximum, but it can run multiple containers, not just one.
Okay. So you can
All right.
maybe go ahead. Yeah.
I think that's pretty much it. I've lost the deployment file for the backend. I would like to pose that as a challenge to the audience. If someone can create a deployment file for the backend, just clone the source code and put it in there. That would, I was really excited to show that because now I would have shown you how they communicate. But yeah, shit happened, I guess. All right. So to recap on what we've studied, and especially in the context of deploying applications using Vagrant, these steps you can replace with any infrastructure as code tool. You can replace with CloudFormation or Jenkins. And then after that, I think pretty much from step 4 to step 6, they remain standard across all Kubernetes nodes. So to deploy an application, you need to create the manifest. So you need the namespace, the deployment, and the service. The deployment specify which image you want to run. The namespace, of course, sort of creates a small virtual environment in terms of how can I put it? It just separates your application from other applications running on the cluster, because in some cases, in the case of microservices, you might want to have applications running on different namespaces and not communicating with each other at all, but they might be communicating with the same database. A service is what gives you application networking capabilities. In our case, we are using a service type called a node port. In some cases, you might use a node balancer. There are, I think, around 3. You could explore more on that and see what they do. So yeah, once you create the object, you just run this command in the master node, which will fire up your containers. Now, the Kubernetes documentation is quite detailed, I guess. I use it a lot. As you can see, I have this open here. So I just go here and I try to see what a command does and how I can use it. They've written very beautiful documentation. So I would really recommend you use the official documentation. Yeah, and I think that's pretty much it. Application is still running. I don't know why it's saying pending, but it's still running. The backend is, of course, not working, but yeah, we can work on that later.
Hey, thank you.
Yes.
So do you have the repository? The repository that you had shared earlier. Does it have the backend?
Yes, it has the backend, but not the manifest for the backend. I had it locally.
Oh, okay.
But
Okay,
yeah.
Okay.
I'll create it again and just deploy it there for someone to have a look at it. Yeah.
Okay. Hey, so maybe you'll share the link so that we can also share in the, or you can share it in our group, WhatsApp group.
Oh yeah, I'll share in the WhatsApp group. Yeah.
Hey, thank you very much. So that will bring us to the end of the session. And thank you guys for joining. We'll be sharing this recording. We'll put it on our YouTube channel and share the link so that you guys can be able to access it. And we'll be having meetings every Sunday, the coming Sundays. So ensure that you follow us and stay updated on our social media, and also join our WhatsApp group so that you can get communication in time. So that is it, guys. I wish you guys a good night and a good week ahead.
Samuel.
See you next. Yes.
There's someone.
Yes.
Someone asked a question that I think is very important to answer. I think they were confused on how Docker communicates with our Kubernetes cluster. How is the interaction between Vagrant and Docker happening? Does the VM that I create using Vagrant contain Docker running inside it? No, it does not have Docker. If you come inside one of the virtual machine and you write Docker, it tells you command not found. So once you build a container image, where you're running it, the server does not care whether you're using Docker or what. It only cares about the container runtime. We call it a container runtime. And when I was setting up my Vagrant machine, I specified here inside the script what we call container. Now, this is what handles the image, the container. This is what runs the container. So the server does not care whether you're using Docker or you can use any container runtime you want as long as you have the image. Yeah.
Okay.
Oh,
Sorry,
Samuel. I interrupted, but yeah, sure.
Yeah, so I can see a request to join the WhatsApp group. So here is the link. I'm sharing it on the chat. If you're not on the WhatsApp group, so that is the overflow group. So the initial group is full, but we post everything on each group. So you are still be able to access all information, and you can still be able to contribute in that group as well. So I've shared on the chat, so you can join that one. I'll see you guys.
All right, thank you.
Okay, bye-bye. Feel free to drop, everyone.